Welcome to 6WIN's vRouter webinar, where we will present our new Turbo CG-NAT vRouter beta program. My name is Kelly LeBlanc. I run 6WIN's marketing program and am based in Santa Clara, California. Joining me is Jan Rappaport, 6WIN's VP of Product Management. Jan will introduce our new Turbo CG-NAT vRouter, including a demo. At the end, I'll share how to join our Turbo CG-NAT beta program. We will conclude with a Q&A. Please use the Q&A button at the bottom of your screen to submit your questions, and we will answer them in the order that they are received. First, let me start with a quick introduction of 6WIN. 6WIN is a software company headquartered in France with offices around the world, including Santa Clara, California, and Beijing, China. We make high-performance networking software with deep expertise in telecom. In recognition of our innovation, we received an investment from Cisco and a vRouter Innovators Award from IDC. For those of you from the developers community, you may know us as the founders of dpdk.org and a top contributor. Here's an overview of our software product portfolio. Our initial flagship product, 6WIN Gate, is a complete Layer 2 through Layer 4 networking stack available in source code form factor, optimized for standard commercial off-the-shelf servers, including x86 and ARM architectures. 6WIN Gate is integrated by OEM vendors to develop a complete networking appliance, solution, or system. 6WIN Gate is used to build 6WIN's vRouter software solutions. 6WIN Virtual Accelerator is a vRouter that fulfills all the requirements to power the hypervisor with the necessary features for virtual networking infrastructure used in NFV, data center virtualization, and network appliance virtualization use cases. 6WIN Turbo Router, Turbo IPsec, and our new Turbo CG-NAT are vRouters in the form of software appliances that lead the market with a performance advantage. Popular use cases include border routers, IPsec VPN gateways, security for mobile infrastructure, Carrier Grade NAT, and more. OEMs such as Cisco, Nokia, NEC, Mavenir, Nuage, and many others have been using our 6WIN Gate source code to build their own products for over a decade. Service providers and enterprises such as Arbor Networks, AT&T, and OVH use our vRouters to build their networks and services. In today's webinar, we will start with an overview of our Turbo CG-NAT vRouter, followed by a demo. Then we will share how to join our beta program. At the end, we will have time for Q&A. Let's get started. I will now turn it over to Jan.
Thank you, Kelly. Let me start with a quick overview of CG-NAT, also known as Carrier Grade NAT or Large-Scale NAT. Carrier Grade NAT helps ISPs with IPv4 resource conservation by sharing an outside IP address among multiple inside local private IP addresses. Benefits includes the ability to use a pool of public IP addresses instead of one, the ability to limit resource usage per user, in addition to transparent translation schemes. SixWin's Turbo CG-NAT is a high-performance software alternative to hardware-based CG-NAT solutions for ISPs who are looking to increase flexibility and lower costs. It is a high-performance CG-NAT vRouter solution for white box networking. We support the required networking protocols in our vRouter form factor to run high-performance CG-NAT solutions on Intel-based servers. This includes NAT 4.4, NAT 6.4 in our near-term roadmap, port assignment, IP pool management, logging, ALG support, hairpinning, mapping, filtering, and more. You can see our system requirements, which are also available in our Turbo CG-NAT datasheet online. 6WIN's vRouter brings our pedigree of scalable software performance to CG-NAT use cases. Here you can see our benchmarks on dual Xeon Platinum 8170 processors. We deliver 30 million simultaneous connections per 25 gig of RAM, 200,000 connections per second per core, and 10 gigabit per second per core. 6WIND software scales linearly with the number of cores. If you need more performance, simply add more cores to the configuration. Once again, this is a testament to the power of white box networking. The vRouter comes with an industry standard CLI, including help and completion. The CLI is organized in contexts that can be browsed in the same way as a file system. Here is a very simple CG-NAT configuration example. We see the pool of public IP addresses with port range and block size, a rule to match incoming packets from the LAN based on IP address and NAT them towards the WAN, and a set of contract options to fine-tune the behavior of the CG-NAT. The vRouter management is based on NETCONF and Yang, and the CLI is actually a NETCONF client. Here is the same configuration in XML as sent from the CLI to the NETCONF server. You can see here the same information about the CG-NAT pool, rule, and tuning options. NETCONF is a standard for integration with third-party management frameworks, and it is the API for an automated programmatic configuration of the vRouter. Regarding monitoring, Turbo CG-NAT supports monitoring through the CLI or NETCONF in order to dump CG-NAT statistics, including high-level counters, allocation errors, per pool and per rule counters, in order to optimize the CG-NAT configuration according to the user traffic. The goal is to minimize the number of public IP addresses used while maximizing the service, that is, the number of ports available to users. In addition to granular monitoring, Yang-based KPIs are provided for streaming to a time series database. This allows to track statistics against time and therefore get a thorough understanding of the system dynamics to better optimize the configuration. The time series information can be displayed in the graphical analytics framework. As an example, we have pre-integrated Turbo CG-NAT with the InfluxDB time series database and the Grafana analytics framework. We track system information such as CPU usage, memory, network interfaces and their throughput, CG-NAT statistics, and more. InfluxDB Grafana is just an example of integration, and the same APIs can be used for integration with other frameworks such as Elastic, Prometheus, and more. Let's conclude our review of the main Turbo CG-NAT features with logging. It is a legal requirement for an ISP to be able to provide the mapping between a user and a public IP address at a given point in time. When millions of connections are involved, it is just useless to try to log them one by one. That's why Turbo CG-NAT comes with a compact log feature that consists in logging allocation of blocks. The logs can be retrieved into a logging framework such as Elastic's Logstash to parse them and be able to perform efficient searches. We will illustrate this in our demo in a few minutes. Now let's get ready for our demo. This is our demo platform with Turbo CG-NAT standing in the ISP's core network between the customers and internet. The customers are varied, including homes, enterprises, and universities. And the services they access can be web browsing, file servers, streaming, or cloud services, and more, resulting in millions of simultaneous connections. This is the addressing scheme for our demo. And we run Turbo CG-NAT as a VM on 2 cores of a single-socket Xeon E5-2697 V2 CPU, and we use an Ixia XT80 traffic generator to simulate the customers and internet services. Let's start by reviewing the CG-NAT configuration using the CLI. Using the showconfig command, we can dump the interfaces, showing 2 interfaces connected to the LAN, 2 connected to the WAN, and 1 for the management. By using 2 pairs of 10 gig interfaces, we will be able to demonstrate 20 gigabit per second of traffic. Now, let's check the routing configuration. In this case, it is very simple, with static routes used towards the private and public networks. Black hole routes are responsible for dropping the incoming public traffic that doesn't match an existing connection. Next comes the CG-NAT configuration itself. In our case, we have 2 pools of public IP addresses configured with their block size and port range. Rules are responsible for matching the LAN networks according to the source IP address and NATing them through the corresponding WAN interface using the right pool. Rules also include per-user configuration information, such as maximum number of blocks and endpoint filtering scheme. Finally, global options for the management of connections are configured. In our case, the timeout of connections is tuned for the purpose of benchmarking. We can see as well that logging is enabled. We can check the configuration in XML format. This is what a NetConf client would send to the vRouter to configure it in a programmatic way. We see the routes, the rules and tools, CG-NAT global options, etc. Now, let's switch to the Ixia traffic generator. This is the configuration screen for the IXLoad software, where we see the HTTP clients on the left connected to the LAN interfaces of the vRouter, and the corresponding servers on the right connected to the WAN interfaces. These simulate the customers on the LAN side and the internet services on the WAN side. In this first test, we have configured the Ixia to reach 10 million connections and maximize the number of connections per second using a minimum HTTP page size of 1 byte. The Ixia starts by establishing connections at a fixed rate and then opens and closes connections continuously while transferring traffic to reach a maximum number of 370K connections per second with this 2-cores configuration. The throughput is not maximized in this case as we use a small page size. Let's now have a look at the KPIs in the CLI. These key performance indicators include product information, such as license and version, system information, such as CPU or memory usage, networking statistics, including CG-NAT, and others. These are streamed from the vRouter to an InfluxDB time series database. They will be displayed in the Grafana analytics dashboard for a better analysis of the dynamics of the system. In the dashboard, we can see the CG-NAT statistics evolve over time while the traffic is running. The CG-NAT filling section includes information about the status of the CG-NAT blocks, contracts, CPEs, and NAT session tables. The blocks and CPEs section shows the total number of blocks allocated and CPEs, their rate of creation, and possible allocation errors. The same information is displayed for actual sections or contracts in the section below. All these statistics are very useful to adapt the configuration of the system to the actual traffic and tune the total number of blocks per CPEs, the public IP pools, and the port ranges to minimize the number of public IP addresses used while maximizing the services offered to customers. Scrolling through the dashboard, we can see the throughput on the interfaces. It's quite low in this case as the goal was to maximize the CPS. And we can also see disk usage and process usage. And up in the dashboard, we see the total RAM and CPU usage. Back to the CG-NAT counters, we see our max CPS number of 370K. Let's now quickly switch to another Ixia throughput test. The Ixia is configured to reach 10 million connections per second this time maximizing the throughput. Traffic is injected as soon as the 10 million connections are established using pages of 32 kilobytes. This results in a maximized throughput of 20 gigabit per second with our 2-cores configuration. During this test, the Grafana dashboard shows that the interfaces are running at wire speed on both the LAN and WAN sides. Let's now check the CG-NAT logs. We can dump them from the CLI and see the new block allocations with the private IP address, public address in the pool, and port range. It is also possible to filter the output on a single IP address using the match feature of the CLI. However, the amount of logs available in the system is quickly limited by the disk space, and it is preferable to integrate the logs with a more complete logging framework. For this demo, we have integrated the vRouter with Logstash and Kibana from the Elastic Stack. We see the timestamp, the type of action, the private IP address, protocol, public IP address, and port range. Using a Kibana filter, we can see, for example, all block creations. Another more advanced filter will give us the logs for a single IP address and port, which gives the corresponding private IP address in case the ISP gets a request from the authorities, for example. To conclude this demo, let's have a look at advanced CG-NAT show commands in the CLI. These commands help fine-tune the CG-NAT configuration. The first one provides high-level counters, including packets passed and blocked, hairpinning, NAT and CG-NAT entries with port block allocations and invalid cases. Another one gives the status of the CG-NAT tables. A command is available to show statistics per rule with block allocation per protocol, port, block, and public IP allocation errors. Another one shows contracts per user, including private source IP and port, protocol, public IP and destination port, and contract state. And the last three provide detailed port and block allocation statistics per rule and block allocation statistics per pool. This concludes my CG-NAT vRouter demo. You can see the power and flexibility of our software-based Carrier Grade NAT solution as an alternative to hardware. Now, I'll hand it back to Kelly.
Thank you, Jan. That was a very nice demo. Now I'll have a quick word about our Turbo CG-NAT beta program before we open it up to Q&A. So for those of you who are interested to join our beta program, you can start your evaluation today. The process is very simple. Just click on the evaluation button through any page on our website and select Turbo CG-NAT beta. We are specifically looking for beta testers to share feedback on the following features and management. The process is to complete this simple form at the end of your evaluation. Okay, so now we can see that there are many questions coming in. So let's open it up to the Q&A, and we've reserved some time for this. Remember to use the Q&A button at the bottom of your screen to submit your question. So many of these questions I can see are technical questions based on Jan's demo. So I see we have one on licensing, which I'll take, and then we'll hand it over to Jan to go over the technical questions. So the first question we have, how do you license your Turbo CG-NAT vRouter? Okay, so we license according to your throughput and number of connection requirements. For throughput, we start with 1 gigabit per second and go up to 200 gigabits per second. For simultaneous connections, we start with 1 million and go up to 30 million simultaneous connections. Okay, so for the next question, handing it over to Jan. So we have questions about our rules. Are they flexible?
Yes, so thank you for the question. So yes, the rules are flexible, so we can match the packets based on the usual tuple, and we can from there we can associate the packets to the different pools, and we have a bunch of configuration options to explain how the CG-NAT should work on the rules. So to extensively answer this question, we should be in touch to see all the details of the question, of course.
And I think the question continues here. So for the same private IP, if more IPs are needed, how do I do it? Do I need a new rule?
So it's possible to add new IP addresses to the pool to extend the size of the pool. And similarly, we support dynamic extensions of many different CG-NAT parameters.
Okay, great. Next one. Does CG-NAT support recovery? Do we have some backup mechanism?
So we support HA in our vRouter. This is based on VRRP to be able to have an active and passive framework. So that would enable a passive CG-NAT system to take over the connection if the active one fails. And this, at the moment, this requires to reestablish the connections. So as you know, it's the beginning of our beta program. So we are gathering requirements regarding a possible continuous synchronization of HA. I think there is another similar question on that theme. So it's a good time to discuss your requirements regarding recovery and high availability.
Yes, I see a continuation on a clustering mechanism, session synchronization, and config synchronization.
Yes, it's a similar question. So for the configuration synchronization, we will configure the active and passive CG-NAT with the same configuration using, for example, our NETCONF API for automation to make sure you easily apply the same configuration on both sides. And as of today, for session synchronization, we don't support it, but it's something we consider. So we are open to discuss.
Okay, let's work through the next question. It's a detailed question. So we have two network edges where we connect via eBGP to transit providers and directly pair with some content providers such as Netflix. There is not guarantee that a connection that goes out of our network at one edge will come back in through the same edge. Is it possible for your solution to work in such a scenario? Is there some kind of NAT table synchronization between devices that would allow this to work?
Yeah, so actually it comes to the same question about synchronization. So we should discuss here for such detailed use cases. We should discuss, bring in our experts and see how to address this use case.
Okay. Is there any limitation on the number of rules or minimum block sizes?
No, so we don't. That's the benefits of a pure software solution. We are only bound by memory. So today in our benchmark, we showed 10 million connections. We have measured 30 million connections per 25 gigabytes of RAM, and the boundary for the scalability in terms of number of objects is memory.
Okay, let's see. So we have a question about multi-partition. And the question is, do we have anything similar to competitors' multi-partitions? Let's maybe talk a little bit about multi-partition if we want.
Maybe we should take that offline, Kelly.
That's a good idea. Okay, let's do that. Okay. Since your solution is hooking to multiple external WAN connections, does your solution support BGP for WAN connectivity and shortest path routing?
Yes, so we do support BGP. You may know CXWIND has a strong history in providing vRouter solution, and one of the first vRouter solutions we provide is Turbo Router, which is a pure routing software appliance, and we support BGP, we support OSPF, we support RIP. So Turbo CG-NAT includes these routing features.
Okay, great. Okay, I think for the rest of the Q&As I see on this current string, continuing the discussion, which we can take offline. So I'll move back to some additional questions we received. So what's the performance of your CG-NAT?
Yes, so we have measured on high-end dual Xeon Platinum up to 30 million connections per 25 gig of RAM, as I said, and this scales with the amount of memory. We have measured 200K connections per second per core, scaling this time with the number of cores, and 10 gigabit per second of throughput per core, scaling with the number of cores. In our demo, just to remind you, it was a less powerful platform for this demo, and we have measured 10 million connections. We've shown 370K connections per second and 20 gigabit per second of throughput, that was using 2 cores.
Okay, and great. We have another question with NAT and without NAT. What is the impact?
I'm not sure to get this question, so maybe let's take that offline and discuss in more details. Yes.
Yes. Okay. I see. It's continuing a string. So good idea. So next one, have you integrated your vRouter with any management frameworks?
Yes. So as we've shown, we have different APIs for the integration of our vRouter. So first, CXWIND has a strong history with tier 1 network equipment providers. So these guys have integrated with their own management frameworks, so commercial or homemade management frameworks. For monitoring, we have an example with InfluxDB Grafana, and we provide the right APIs for integration with also other third-party monitoring frameworks. We've also some experience of integration with frameworks like Nagios for monitoring. And finally, there is orchestration with VMware, OpenStack, etc. And so in general, our vRouters are included in these kind of frameworks, whether they are commercial, open source, or proprietary versions, thanks to our APIs. And specifically for CG-NAT, so we have the NETCONF management of the vRouter, and we provide a Grafana dashboard, as we have seen. So it's an example that we provide, and it includes the filling of the CG-NAT tables, the number of rate of users, blogs, sessions, etc. And for the logs, as we have seen, we have integrated with the Elastic Stack, specifically with Logstash and Kibana for a nice visualization and search tool in order to comply with the legal requirements.
Okay, I think we have time for 2 more questions. So next one, is your solution OpenStack compliant?
Yes, so we are OpenStack compliant. We can be deployed in OpenStack as a standard virtual machine.
Okay, and last one, and anyone who we haven't responded to yet, we will take these offline with you. Just getting a lot of questions right now. So last question will be, do I need a specific license to deploy in virtual machines?
No, because it's pure software. Our vRouter supports both bare metal and virtual machine deployments, and that's with the same software license. So you can deploy in bare metal with PXE, ISO, USB installation. And for VMs, we provide ready-to-use packages, OVA or QCO2, whether you deploy in VMware or in KVM or in OpenStack. And we support Cloud Init for VMs for the customization of the startup. So the same license covers all these features, bare metal and VMs.
Great, thank you, Jan. That's all the time we have now for questions. So thank you all for your questions. Our Q&A session is now over, and this concludes our webinar. If you have additional questions, and this includes the questions that we haven't been able to address yet, please don't hesitate to contact me directly. I'm happy to help. We look forward to hearing from you soon. Bye for now.